Good morning. My name is Brendan Tierney, and the title of the presentation that I'll be giving is Real-World Machine Learning Projects. Okay, so the presentation is kind of going to be divided into three main parts. The first part is just a bit of background to what machine learning is, just so we can get that kind of context together. The middle bit is talking about the real-world machine learning projects. So these are projects that I've worked on, okay? And I'll explain some of the issues and the challenges that we've had around it, which will then bring me to the last part of the presentation, which will look at some of the main issues that we had and what are the main kind of challenges that we have when we go about doing these projects. And I'll give you a little hint. None of them are technical. None of them are stats or mathematics, okay, about doing these projects. So there's lots of other types of challenges that we face when doing these projects. So a little bit of who I am. I'm a Oralytics director, I'm a groundbreaker ambassador. I come from Ireland, so apologies to anyone from the UK in the audience, soon to be the only English-speaking country in Europe. Although the people from the UK will claim I don't speak English. I speak some variation of it, but anyway. So I've written a few books. Was it just 3-4 books there? The last one there is a kind of, it's a small little book, so it's there on Amazon. It's actually one of our bestsellers from last year in the machine learning. You won't see a line of mathematics in it. You won't see a line of code in it. It's just explaining it at a kind of a more higher level. So if you want to give a birthday present or a Christmas present to your manager, that would be a good book to go and have a read of. I've been working with data all my life, or since my working world. So that kind of started off around 93, which makes me feel really old. All right. So, but the very first project I worked on today would be classed as a machine learning project, but it wasn't at that time. But it was the same task that we did, the same kind of problems we were trying to solve as what you hear about today. But what we did is we just wrote some SQL code and some PL SQL code to be able to find certain patterns on it. Now, if you go and kind of Google me, I do recommend that you put in something other than Brendan Tierney. So, because otherwise you're going to get someone like, you're going to get someone like this, right, who's a cage fighter based in New York. Okay, so just in case there's any confusion, that's not me. All right, so like he didn't write those books and he doesn't kind of do this kind of stuff. Okay, so just to avoid that. Now, before we begin, I just want to get a feel from everyone here about your background. So is there anybody here doing machine learning? Hands up high. Right, and we have someone going, maybe not, right? So there was a small number of hands kind of going up. And, whenever I ask, audiences like yourselves is how many people are really doing it, you might get more hands going up, all right? But then it usually comes down to is, well, of all of those hands that went up, how many of you have done an online course? Oh, so we get more people going up. So we get kind of different flavors of it. How many people are actually developing machine learning in their applications or in their life? Excellent. So put the hands up again. I think a few went up at the very end. So we have 3-4 hands going up, all right? So small number, right? Even though this is kind of a topic that has been around for a long time. Of those that put up their hands, how many of you got machine learning in production? Okay, some of the same hands, all right? So small numbers that are getting there, but this is something that sometimes is a topic that can scare developers off. So in reality, if you're a developer, you can already be a machine learning data science superhero, all right? Who wants to be a superhero? All right? Come on, a lot more of you want to put up your hands, right? So hopefully by the end of it, you will be able to become a superhero and realize you can be a superhero. Anybody doing machine learning using Oracle technologies? Where's Grant? Yeah, the one hand. So hands up again, who's using Oracle technologies for machine learning? So there's a few hands went up. Anybody using R? Okay. SAS, SPSS, okay. All right, I'm getting to Python. All right. Who's using Python? Yeah? All right, so now there's actually some issues about doing machine learning in Python, but anyway, that's probably a conversation that we can have over coffee afterwards, okay? Anybody using something else? What are you using? Okay, IBM and Amazon services for it, okay? All right, and then I take it from the lack of hands going up around the room is that most of you are not doing it, but maybe would like to do some in the future, yeah, and being able to do it. So yes, lots of hands going up, which is good. All right, now when we start talking about machine learning, we need to be careful of the context of it and the phrasing that we are using in regards to all of this. Because if I go back over the last, say, since I started working on it, which is 26 years ago, we've gone through a variety of different terms for it. So we've gone through from the stages of doing data mining into advanced analytics, into predictive analytics, into machine learning. And what's the phrase that's being used a lot now? Artificial intelligence, AI. All right? Now, when we start looking at how the industry has progressed over that time, is in a lot of cases they're using these different words to mean the same thing. So when you start reading about it, you need to try and define the context of what we're actually doing in it. And if we kind of get the more pure theoretical aspects of it, each one of these phrases are almost like a subset of each other. Okay, from the deep learning, I'll mention that in a little bit, into some representational meaning, into machine learning, into AI. So, we're kind of broadening out the scope of it and being able to bring in a lot more other IT tech. So the further out you go, the more general it becomes. So everyone that put up their hand there a few minutes ago about who wants to be doing it, this means you can go and do it. And it's becoming easier and easier as we progress through. But when we start looking at this, it does become a little bit kind of confusing about what we need to be able to do on it. So if we look at some definitions to do with data mining, all right? So it's the field of study that gives computers the ability to learn without being explicitly programmed. All right? Do you see the date for that definition? And this is the most commonly used definition of it. How many of us were born back then? I'll put down my hand, all right? All right, it's been around for a long time. And then we have something from 97, all right? So, if we read out that definition, when we start reading this definition, everybody read it? Sometimes it feels like, oh man, what is actually going on here, right? My head hurts and all of this. It's kind of making it really complex. And it doesn't have to be complex. It doesn't have to be a really difficult thing. But when we start looking at lots and lots of other definitions of what machine learning is, very few of them get into the technical aspects of it. Most of them are about trying to find patterns in our data, being able to use some code to be able to find patterns or to be able to explain certain things within our data. But probably, when we start looking at all these, again, my head starts to hurt. But one of the best definitions I've come across in recent times is from a blog post from last year. Machine learning is a thing labeler. It just labels things. It doesn't do anything fancy. It doesn't do anything, well, it does quite nice stuff under the hood. And yes, there's lots of statistics and maths and lots of complex computing goes on under the hood. It's just like, do we need to know and understand all of that to be able to do machine learning? The answer is no. We might need to have some understanding, but the deep understanding of it, we don't need. How many of you have used an average function? How many of you know and understand the maths behind it? Understand it, right? Yeah, far fewer hands have put it in. But you know what it kind of does. You know what data needs to go into it. And you know what the result comes out roughly means. All right? So you can apply that to machine learning. So we have lots of libraries and lots of functions available to us that once we know how to use it, then we can actually build these very easily into our applications and being able to get something a lot more useful out of it. So that's just kind of getting into the thing label or description about it, right? But that is a very simple description, but it doesn't sound very interesting. But sometimes when you hear about this, we have to make it really complicated. We have to make it sound so awesome and so incredible. But it's just really a simple task that we're actually trying to do. All right. So we're getting at kind of different things. Now, if we go to CEO of Amazon, he's actually got a couple of quotes that are actually quite interesting, where most of what developers try to do is kind of take different scenarios and being able to write the code to map out those scenarios or to look for certain patterns or certain events and being able to map out the code for that. Where the machine learning comes in is that, well, some of these patterns and some of these behavioral things within our data is not necessarily easy to work out. So what we need to use is like some of these tools to be able to help to identify those patterns and being able to work out whether Brendan is a good customer or a bad customer, or whether it's his car insurance, should we double it or treble it rather than giving him a cut in his car insurance. All right? So we're trying to find those patterns, right? But sometimes we get lost on some of the examples that are in there, like the typical scenario of looking for pictures of my cat and dog. And you're kind of looking into the real world scenarios, how applicable are those kind of examples? Okay. The other challenge that we face with machine learning, data science, AI, or whatever it might be, is that we always see, if you're doing it, you can solve lots of problems in these areas. And this is like the 10-year challenge. You remember, has somebody kind of come across the 10-year challenge thing? So if I was to look at data mining, see the years up here? The data mining challenge, machine learning, just add on 10 years, the exact same list will be used, and then with AI, the exact same list is being used. Right? You'll see this if you kind of go back through the literature over that period of time. But not only that is, hey, if you have big data, you can do all of this. If you're in the cloud, you can do all of this. Or if you're in the hybrid cloud, you can do all of this. Or what you do is you hire all of these graduates, these young people, graduates that have got lots of experience in doing machine learning, because us slightly older, and I'll class myself as that, we couldn't possibly do that. But we can very, very easily be able to do that. Now, the cloud has changed things quite considerably when it comes to building out applications into production so that we can have things running efficiently across all of that. It's a lovely diagram, isn't it? All right. So if you're kind of really getting into this area, is that there's quite a large number of skills that, in theory, you should have. How many people in this room would have all of those skills? Go on, be brave, right? Nobody's putting up their hand. Somebody's getting pressure to put up their hand over there or something, right? Right? So in a way, you have to become a bit of a superhero, right? To be able to be able to do this, if you believe the literature. And the reality is, well, nobody's going to have all of those skills, and even superheroes don't have all the possible skills to defeat the bad guy. So, but what to do is, it's just, if you're creating this team, is you're going to have a number of members of your team that are going to be effectively superheroes. Right? You may have some people that are working with the data. You may have some people working on the visualizations. You may have people working on various different analytics. You have your developers that are going to be creating the applications that all our users are going to be using. Each one of you can be effectively a machine learning superhero in relation to all of this. Okay? So before we get on to the projects, just a couple of final things on the context of it. A lot of what you hear about machine learning is all about either the algorithms. It's all about the algorithms and the maths and statistics behind them, and it has to be all difficult and complex, and either it's a maximization or minimization problem, and it's just all of this. And nothing else matters. It's just like the example I gave of, was it the count or the average function a few minutes ago, is that, well, maybe we need to have a little bit of an understanding of it. Some people that are brighter and better than us have gone off and developed all of this, so let's just reuse their code to be able to solve problems that we are after. So when you start kind of looking at, it's all about the data, it's all about the algorithms, the wrong approach to take, What we're trying to do is solve real world business problems, which is, as a developer, that's your day-to-day kind of life in reality. So when we go about trying to solve these, the first thing you need to do is you need to work out, well, what are you trying to do? Again, you don't start with the maths or the algorithms, you don't start with the data, you're trying to solve a problem. And most of you, in your you have your applications. It's just like, well, there's your business problem. It's like, how can I actually add, maybe machine learning or some advanced analytical techniques to be able to help us to do that? From there, then you can define is what do you want to be able to achieve? Now, we'd like to be able to achieve world domination or whatever it might be. But maybe we can do is small incremental improvements as we go along. And by doing that, we can get a better return out of it. And it's only after defining what you want to be able to do and, and why you want to do it, is then you can work out what data is relevant. So it doesn't matter how much volume you have, right? You're not going to use all your data to solve one tiny little problem. You're going to use the data that's going to be relevant to it. All right? And from there, then, the real value with all of this within the machine learning is about putting it into production. You get people to use it. There's no point in being a report or a spreadsheet or something on a dashboard. You need to be able to integrate an awful lot of these machine learning techniques into production, being able to deploy it, just like the chatbots, being able to get it out there on your websites or whatever it might be. You need to get it out there, and that's where you're going to get the most value and the most return, and when you get that nice little pay rise for your innovation work at the end of the financial year. So it's another tool in our toolbox. Just like all the different libraries that we might want to import, whether you use an R or Python or something else, is that we have different libraries that we can import to do lots of different kind of things for ourselves. And this kind of reminds me a little bit of Lego. Is when we start working with Lego. Everybody likes Lego? Yeah, good. All right. So is when we start organizing it, we can get into like the BI world, the business intelligence world of sorting data and arranging it and trying to see certain distributions on it. But the real value is when we start taking the different components from that kind of sorting and we start building some useful products. Now we can start building something nice and simple, or we can get into something a little bit more complex. But what we have is the same kind of tools that we're using to build that house into something a little bit more complicated, into something that's integrated in with a Raspberry Pi that's built out the infrastructure is built out of Lego doing sorting of a Rubik's Cube. We're still using the same components, but it's about how we actually go about using it. And finally, lots of surveys. So lots of surveys, every December and January about what are the key trends for developers and lots of other industries on it. For developers, the number one that, earlier this year has always been about being able to embed intelligence into your application. So it's effectively embed the machine learning and other kind of advanced analytical techniques within it. But we do need to be careful. Is that, despite the IKEA instructions, we've always ended up with spare bits or things in the wrong order and stuff like that. Is that even though we may have the right equipment, the right tools, the right instructions, we mightn't always end up with the ideal solution. So this is maybe sometimes if we want to use the term data science, we're trying to learn and evolve and experiment to find out what works for us. All right. The important word there is the third one. So data. What we need is data. Big, small, or whatever it is. So sometimes people get put off from doing these projects because, hey, we don't have big data. We don't have a gazillion amount of data. Once you have data, you can do these projects. That's the important bit. So you don't necessarily need to have big data to be able to do it. All right? Sometimes machine learning is kind of being overused when they're talking about doing that average function. Is that machine learning? Right? So we're building in analytics. We need to be careful of it. And the other one is, that deep learning kind of scenario of it. So kind of say it one more time, but we'll come back kind of to usefulness. But the problem with the big learning examples is you're always going to see examples of, well, it's great for sorting photographs, right? And I can identify me in a photograph, or I can identify my cat or dog in a photograph and whatever else. How useful is that? Now, I have a couple of examples of how we've gone about kind of using this technology to be able to solve it. So it's a little bit of theory versus reality, all right? So you hear a lot of it out in the press and a lot of kind of people talking about it. And what I'm going to talk about is reality projects. So it's kind of like the McDonald's burger, right? Or you order something off the internet, the Christmas tree, and it's kind of like the box versus the photograph. Or if you go and buy clothes on it, all right? Don't worry, the mails, I'm going to come back to you now in a moment, all right? So an awful lot what you hear about is theory or projects that exist on PowerPoint slides, all right? So everything I'm going to show you today is something that I have worked on, okay? So it's on real projects using real data, real, production type in environments, real problems. So these are not made up, okay? These are there. So remember when I said I was going to pick on the men in a moment, right? So it's kind of like, the theory versus reality of it. Now, the first project I'm going to tell you about is one I can't tell you about, which is not really a good way to start, is it? But there's been a pretty much exact same project being kind of publicized, by an Oracle customer, which is to FizServe. And this is to do with electronic payments. So trying to look, banks and kind of clearinghouses trying to look for fraud within financial trading of it. And the problem with looking for fraud is that fraudsters change their behavior very regularly. So they're constantly changing and evolving so they can't be detected. Now, in this particular case, they identified that, the fraudsters change their behavior roughly every 3 days. It's kind of 2.5 to 4 days, kind of, depending on what country you're dealing with. And in order to be able to identify those is that, you can build a solution. Now, you can go down the machine learning route of trying to find the most optimal model possible, the most optimal way of finding those fraudulent transactions. But the process that I encountered and they encountered is that in order to be able to do that, it was taken about 5 days of work of retraining the models, of building up the models, retraining them on new data, and then integrating it and deploying it in production. The fraudsters have already, or most of them will have changed their behavior at least once, maybe twice within that period of time. So you're catching a very small amount of fraud in those scenarios. But there is this concept of, is it good enough? All right? So if you get into like the theory, they'll always say you have to tune your model to get incremental improvements. And some of those incremental improvements might be 0.1%. All right? So what we end up by discovering is that, we can use an algorithm that wasn't as accurate as the most accurate model, but we were able to rebuild it and deploy it within 6 hours versus the 5 days, all right? So it's much quicker. Now, it wasn't catching the same percentage of it, but it was working in production for a longer period of time before the fraudsters changed their behavior, and in that case, the percentage of fraud detection increased dramatically. All right? So the idea of this getting the most optimal model possible mightn't be the best one for you to deploy in your workplace or on your particular problem. You have to keep in mind the time frames around it and being able to kind of work within all of that. So it's a little bit of the Nike approach of just do it. We can spend lots of time trying to tune our models, or we can just take something that's good enough, that's given us reasonable kind of accuracy. We can easily deploy it in our production environment, we can easily deploy it in our apps, and we can get instant results. So you're increasing your return on your investment and all of this. Anybody here work for a university? All right. So one of the key things for universities around the world is about student retention. Because the more students you can retain in your courses, the more money you make, right? The more funding or the fees that you're going to get in. Now, different countries will have different funding rules around student retention. So in the UK is that if a student completes the second year, so to get into the third year of their degree, the government will give the university the funding for the entire 3 years, right, or 4 years of the program. So there's a certain incentive for the university to retain them. So once they get into third year, they don't care, right? Yeah, if the students drop out. Only messing, they do care, right? But, is how to look after it. So it's being able to look at, building student retention models. So this has been done in UK and in the US and a couple of other countries. Being able to build those out and being able to predict what students are going to stay and what students are going to leave. So we can actually do things at student application time, student registration, on the very first day to walk into the university. We can start doing predictions on who's going to drop out, who's going to struggle to get through, and who's going to have no problem, completing the courses. And we can start analysing it. And when you start analysing these kind of types of courses, you start to finding lots of interesting behaviour. So maybe it's certain courses that would have a certain title that would appeal to a certain male-female kind of scenario. All right? And then when you walk into the course on day one, you discover that it doesn't have that number of females that you might have expected. And you kind of there's 97 males in a room with 3 females. So that was one of the scenarios that we come up with. So sometimes it's slightly politically sensitive stuff that you come up with. Right? And then there's different ways you can look at how you can support different people that might be doing like postgraduate studies or coming back to studies when they're later in life. So whether they're coming back later towards pension age, or whether they are kind of in their late 20s, early 30s, kind of looking for a bit of a career change. And you can start analysing lots of different things that are going on. So most of what we want to be able to do is how can we actually reduce student churn? And what we effectively did is being able to work through the data. Now, we didn't have big data. We had our data warehouse and data going back over a large number of years, and being able to look at the courses and how they were attending, how often did they log into the network and onto the different virtual learning environments, how they scoring on their assignments and their exams, and being able to progress this. And what we were able to prove is kind of over a period of time is that we were able to accurately predict 82% of who's going to stay and who's going to go, right? And that equates into an awful lot of money, right? So it's kind of around, over 20 million euro worth of savings per year. But, that's on just one particular university. What they can do is take some of that money and then look at, if we want to be able to save that money and to prevent people from leaving and be able to keep it, is maybe we need to put on different supports for the students, being able to restructure certain programs that may have certain student leave kind of issues on it. So there's lots of different ways you can look at kind of building that in to be able to kind of recoup all of that. And the cost of doing some of these can be relatively small compared to the amount of money that you could potentially save from all of this. And if you multiply that saving for kind of, that's taken from one university out across, there's over 100 kind of universities across the UK, you're talking about a potential saving of, I think it was coming out at about 1.6 billion pounds, that's nearly 2 billion euro worth of potential savings each year. So, there's lots of work kind of going on doing that. Has anybody ever had a informal chat or an informal lunch with your manager sometime, that they just out of the blue just invited you out or gave you an extra day holiday or just maybe a little bonus or something like that sometime? No? Well, this is something that's happening a lot over particularly the last 4 years, is that we're using kind of machine learning, be able to predict of when you are going to leave, or how likely you are to leave. All right? So when you're about to have your next performance review or salary review, is that your manager is possibly sitting down, having some machine learning work behind the scenes, being able to predict, well, Brendan has a 90% likelihood of leaving. All right? It's like, oh, well, do we want to keep Brendan? Well, maybe it's like, yeah, Brendan, just go, right? But maybe it's like, oh, we want to keep Brendan. Right? And we can start going in and analysing the data. So this is kind of taken from some of the screenshots from some of the Oracle applications, but we kind of built our own, so I wasn't able to show you those. But it's the same idea. So we can go in and start analysing Brendan, and we can see what attributes that are determining why Brendan is going to leave. And then we can start using the machine learning model to do predictions. So Brendan looks like he's going to leave. So how much of a pay rise do I have to give him to make him stay? So he reversed from someone who's about to leave to someone who's actually going to stay with us. So the might go is, it's only going to take a 5% pay rise to keep me. But if it turns out it's going to take a 50% pay rise to keep me, then yeah, Brendan's not worth it, right? So when you get offered a certain pay rise or a certain bonus, is your manager has probably done some analysis behind the scenes to know what's the minimum they can offer you in order to entice you to stay on for another year and all of that. So lots of different kind of analysis on it. So we can do what-if analysis. So your manager will be there doing that what-if, is if we change some of these characteristics of Brendan, so maybe he's extra holidays, extra training, extra pay rise, extra bonus, whatever it might be, and they can work out which one of these factors actually will have the biggest impact on Brendan being retained. Now, when you start looking at this, it's like we've done this for a number of different kind of global banks and financial institutions, and in one particular one that had over 300,000 different employees, it was in the centre of London, so the employees are only worried about money, right? It's always about the pay rise and the salary and the bonus on it. But what we discovered, a lot of it wasn't necessarily to do with money. If people are unhappy, they're going to leave anyway. But sometimes it's to do with cultural aspects within the organization. So how can we actually engage with the customers a lot more, or with the employees a lot more? How can we make them feel a bit more loved? How can we make them a bit more happier? How can we improve the workplace in order to be able to do that? So they're not only using the machine learning to judge how much of a pay rise or bonus you get, but they're also judging about your engagement level compared to everyone else in the organization and what changes they might need to look at to be able to adopt those to make it better for every one of us, right? So sometimes, it's about the trends that you find within machine learning. It's just like the universities. You may find things that are slightly unexpected or slightly inconsistent. So, the machine learning will find these patterns in it, and sometimes those patterns might be unexpected, which can be a bit of a challenging for your employer to accept, because it goes against standardized work practices or industry trends in relating to that. We all go buying in shops, don't we? Yeah? Or we all go buying on the internet, right? But we'll come back to that, right? So every time you go into like your convenience store or your small stores, is that you'd like to be, or you expect that the product that you want to be able to buy is there on the shelf. Now, some of that is to do with the owner of the shop about being able to work out based on their experience of what products they have and how many they have across the shelf and various different things like that. But the product suppliers also have people employed to go out to all of these shops to try to encourage the shopkeeper to buy more products and to ensure that their products are being positioned in a more kind of efficient or more visible way within it. So when we start looking at this, is that, how can we actually go about doing that? And it's to do with the timing of orders from the different shops versus the timing of when the merchandisers, what we call them, that would go out and visit these shops. So we did this across a number of different kind of countries on it. And we're able to work out, kind of accuracy of, what products are going to be in and out of stock in certain stores based on when the merchandisers went there, and we're able to observe what was happening. And then we're able to get into lots of different things to do with the timing of when you want to go and visit a shop to get the right order, to ensure that the order is put in on time so that they don't ever go out of stock. But it's also to encourage them to buy the appropriate levels of stock, right? So, and being able to do kind of cross-selling of it. So again, being able to use the machine learning to look at these trends across all of these different products. So there was like 280 different products across, many thousands of different stores in each of these countries, and being able to work out the trends and then the timing of when the merchandisers need to go visit, and being able to look at what impact that has, because we need to learn of what works and what doesn't, and constantly evolve and move on from there. You all have mobile phones, yeah? So I won't ask you all to put up your hand, right? Has anybody ever gotten a call from their, or contact from the mobile phone company just saying, we're just checking to see if you're okay, trying to gauge whether you're happy or sad as a customer, or, anybody get a call like that? All right, we get a few hands going up. All right. So what you've been identified as a potential churner is that you exhibit certain characteristics of a customer who's going to leave. But they don't want you to leave as a customer. They want you to stay, because the longer you stay, the more money they can make. Now, there's two types of customers for mobile phone companies. One is the profitable customers, which is only like 20% of the customers, and then 80% of the customers, you're probably just breaking even for most of the mobile phone vendors. So by targeting the profitable ones is that we want to be able to keep those customers and being able to prevent them from leaving. So this is where we end up by creating a whole series of different churn predictions. What we see here is the accuracy isn't as high because there's a certain amount of volatility within kind of the mobile phone scenario of it. But adding to all of this is so we're able to build up marketing campaigns, feeding it into, depending on how much of a churner you might be, so how much of a risk you might be of leaving. You either got a phone call, you might have got a text message, or you might have got a letter or something like that, or an email from the mobile phone company. So depending on the level of risk. So the bigger the risk, the more value that you have, the more personal contact that you're going to have from it. So you can develop lots of this. But expanding beyond that is that we have this concept of social network analysis. How valuable is Brendan as a customer? Brendan spends €80 a month on his mobile phone, but he has no friends, right? How valuable am I to that mobile phone company? Versus, I see Jared down there at the back. I'm going to pick on him. So he gave us the welcome this morning. He was holding up his phone. All right. So where he spends €40 a month, but he's got 50 or 60 friends that he's constantly contacting in a variety of different ways. All right. And most of it is using data. So we can monitor who the network is for each of our customers. So who's the most valuable customer? Jared with his 50 friends, or me with no friends? It's going to be him. It's going to be him. So by being able to use social network analysis techniques, we can actually work out what's the network that we have. Because if Jared moves to another mobile phone company, he's going to bring a certain percentage of that network with him. So you're not just losing his value, but you're losing that whole network value as well. So being able to kind of widen the radius of what we're actually searching on, increases the value of what we're actually kind of producing in all of this. And in addition to that, we can also start looking at how do you actually engage with us as a customer. So if you're checking in on their app, checking your data usage or your call usage or what your bill is, or whether you're on their website or using some of their other services, you can measure how engaged they are as a customer. So by tying together not just their call usage and their social network and how engaged they are with a customer, we can start doing predictions on how likely they are to leave. So we incrementally built all of these up over time to be able to give a more complete and complex kind of solution to all of this. So now we can actually say is somebody's likely to leave within 6 months, 3 months, 2 months, 1 month, and even down to 2 weeks, how likely it is within that time frame. Now, one of the things you kind of think about is that, is this big data? Now, in a large cases, like the main kind of churn prediction, like into the data warehouse, might be classed as big data. But most of the work, particularly on the later stages, was being done on a person's laptop. Now, it was slow. It was really slow. So the results were so good that they were producing that they got upgraded to a desktop. All right? Now it's sitting on a server. Okay, so it kind of within the data center. So it's been kind of integrated a lot better. But being able to prove that this works and the benefits that it brings can greatly improve what we're trying to do. Insurance. Somebody crashed into the back of me last Friday. Right? I'm okay. Right? But being able to look at insurance fraud and insurance claims. So being able to work with insurance companies to look at, how can we use things like natural language processing, clustering, classification, workflows, regulatory requirements, and trying to improve the overall customer experience, being able to build workflows within, for our workplace about identifying as, well, here we have insurance claims comes in, we can get the text of what was actually involved in it, we can apply some the NLP on it, to work out certain trends on it. Does this require a closer inspection of it? Can we do a risk score on it? Can we do certain routing of it, kind of going, yeah, it looks legit, it's under a certain amount of euros, maybe we can just pay it out. Right? We don't have to do any extra things. So it's a way of being able to improve the work practices on all of that. And kind of like a long, long time ago, remember that 26 years ago when I did my first project on it, I discovered last year it's still running, right? That fraud detection kind of scenario on it. So it's kind of a little bit scary. So we have 5 minutes to finish off, so I've been talking too long. Remember the deep learning. All right? Unfortunately, a lot of the deep learning is about being able to identify cats and dogs, all right? So, which is really good. But when we kind of come to a scenario where my cat and my dog is in the photograph, the machine learning kind of goes, I don't know what to do, right? And it'll give possibly a wrong prediction. But where we start getting more benefit out of it is to let them build some proper kind of projects. So this is from kind of the Road Safety Authority video in Ireland, is that one of the biggest problems is to do with driver alertness, right? And as we kind of get tired, or we're driving too much, or we have the kids in the back of the car, or there's lots of other things going on, is can we actually measure driver alertness, and can we build an application that can monitor me while I'm driving and being able to alert me to either waking up or pay more attention or stop doing that? And maybe can also be used maybe by some of the insurance companies, be able to judge how safe of a drive you really are. So we're able to build an app that will actually, you can plug it up on your dashboard and being able to run it, that will tell you how good of a driver you are as you're driving along. Now, you do need effectively 4G for this, right? Being able to do this. So we can do this in real time using like neural networks behind the scenes. So this is where kind of the cloud kind of based kind of solutions comes in, is that as we increase more and more people using this app, we can scale up quite easy on it. So when we're kind of doing this, there's lots of different scenarios you have. Is how safe is this person being? Oh, not at all. Into, well, the kids are there, but they still have eyes front, but they are slightly distraction going on. All right. Into, well, that's a full onslaught, and I'm sure some of us have been in scenarios like that. It's not good, right? We need to be a lot more alert. So this is a way of being visually be able to feed back to us in near real time about our behavior and whether we need to be a little bit more alert on it, all right? And we can start doing all sorts of different things, all right? Or we can do, or many of us sing in the car, but then we have a bit more of a distraction. Now, it doesn't account for musical taste, right? So with one direction there. So if you have kind of bad musical taste, it can't pick that out. But it can watch you and monitor you. Now, when we start looking at this, what are the challenges of it? Is to do with the position of the camera, all right? Using the mobile phone while driving. Now, there's certain legislations within different countries will allow certain usage on that of where it can be. But this can also be the same code can be taken and embedded in a little camera, like I'm plugged into like a Raspberry Pi kind of thing, and being able to communicate through that through the steering wheel. But then we have to look out for objects that might be in the way. But it's also how do we look at and handle left-hand side versus right-hand side driving experience. And that's actually quite a trivial task to do, because you can just do some image processing to turn the image around, and it looks exactly the same. Right, so being able to kind of flip it on its axis. So it's a really cool way to be able to do that and being able to monitor that, but it does involve a little bit of monitoring on it. So the final project is to do with cancer. I think most families have been touched by cancer, or you're aware of kind of cancer in certain ways. So this is kind of working with some of the hospitals in the region about how can we get greater collaboration between the doctors who specialize in treating cancer and the dermatologists, being able to identify certain levels of skin cancer. All right, so that's what we're trying to do, being able to identify that and being able to use machine learning to help do predictions. Because a lot of it is to do with their initial diagnostics is going to be visual. So they're going to be kind of looking at it, following some simple rules, and using something that's a bit of kind of a light up device so they can see a little bit just below the surface of it and being able to determine. And part of that is that, well, you may have something that may be suspicious, but needs closer monitoring. So the last thing you need to have to do, or you'd want to do, is have to visit the hospital the whole time to get it checked. Right? What we've done is we've developed a mobile phone app that can actually, you can hold up against your different molds and record the picture of it. That'll get sent back to the doctor. All right? Or what you can do is, or what the doctor can do is being able to take that and being able to do live scanning of your molds and being able to do feedback through machine learning using neural networks to look at all of this and being able to say is, well, whether this is cancerous or not, but what parts of the image are of particular interest on it. Now, one of the problems that we have is to do with lighting issue. So in a doctor's consultation room is you're going to have different lighting kind of scenarios, and that kind of proved to be a little bit of a challenge for us. So a little bit of a microscope with a selfie light. So those that are into taking selfies, so being able to get that perfect lighting for yourself, combining the two allows us to be able to have that consistency across it. And here we can start doing predictions. So the feedback in the app comes along and tells us here's particular parts of the molds that we want to be able to concentrate on. You know, so if you want to do a biopsy or whatever it might be, it allows you to do kind of extra changes and all of that. Okay, you all got loyalty cards? Yeah? And if you don't have a loyalty card, you probably have a credit card. So a lot of the banks now and the credit card providers are looking at using machine learning to make special offers towards you. So we're kind of building out some solutions to be able to enable all of that. I'll just skip past this one, which is about predictive maintenance. So being able to identify kind of equipment failure and being able to replace it in time before something breaks, because when it breaks, there's a bigger cost associated with it. All right? So the keys to the success in all of this is about defining your problem, defining what you're going to do. How do you want to go about doing it? Is machine learning relevant for you or will suit you for solving these problems? In some cases, the answer is no. It might be some simple statistics or some simple other analysis on it. But being able to know when machine learning can come in, kick in, and being able to help you. And behind all of that is you define your question, define the topic that you're going to go after. What has been done before? Learn from what has been done before. Lots of different analysis has been done. Know how you're going to measure it. Know how you're going to, what data you're going to use, what techniques you're going to use, and then take it out of the lab and put it in production. As soon as you productionalize it, you're going to get a lot more value out of it. Right? It's the most value that you're going to get out of machine learning kind of projects. So kind of just to finish up on the challenges is that a lot of what you might hear might be blue sky thinking and talk about the what ifs and think of what could be possible, versus the people who go in, it's all about the formulas and the maths and the statistics and the complexity behind it. But for a lot of these projects is that most of the problems that we faced weren't technical, weren't machine learning maths kind of aspects of it. A lot of it was to do with people issues, so people believing that this stuff worked, or it was to do with work practices or building out a workflow and things like that, right? It was everything else bar the machine learning. Machine learning was the simplest part of it and usually just consisted of a few lines of code in relation to all of this. Now, we do need to be careful of GDPR in relation to this. And then there is a whole issue to do with ethics about should we be doing this on every single problem of it. And we have a case of, was it Google in the last week tried to set up an ethics board about all our different projects, and then everyone started complaining about it and they weren't able to do it anymore and they disbanded it. So there's lots of different issues around all of this, but the kind of, just because we can do it doesn't mean we should, right? So we need to think about, are we doing the right thing in relation to this? We need to build products, not just new products, but build it into existing products. So your job as the developer is to come along and being able to kind of know what this can do, work out what this can do, and you can be that superhero within your company. Okay. I've slightly overrun, so thank you all for staying. I'll hang around the back or out in the hall out there if you got any questions or want to discuss anything with me. But thank you all for coming.